the mole. So let's introduce the mole concept. Alright, so first of all, what is a mole? Alright, it's not that little brown thing in the yard. It's destroying the grass. It is the SI unit for an amount of substance. Alright, so what is it? It is a mole. So a mole is an amount of any substance that contains the same number of elementary entities as there are atoms, in exactly 12 grams of carbon 12. Right? Carbon 12. That's the same thing as writing 12C, right? That's the same thing. That's the mass number. So 6 protons, 6 neutrons. Alright. So this number is 6.022136736 times 10 to the 23rd. That's a huge number. Huge number. We can't fathom this number. It's a big number. It's also called Avogadro's number. And it has a symbol sometimes of Na. Alright? And the reason we do this, it is necessary, right, to scale up from the microscopic world the microscopic world of single atoms and molecules to the macroscopic world, right? And that was which we can see and manipulate. So, for example, one argon atom weighs 6.63 times 10 to the negative 23 grams, or 40 AMU. Change the color. 1 mole of argon weighs 40 grams. So this is the same number in different units. Alright, so that's what we, let's just write this number out real quick. 102.213 673 600. I think that's it, isn't it? That's a big, big, big number. Alright, that's a huge number. We like this, right? That's 3, 6, 9, 12, 15, 18, 19, 20. Oh, I need more. Yep, there we go. There we go. That's the right number. That's huge. Huge. Right? I mean, if you talk about in terms of money, everybody can get $1, right? $10 is harder. $100 is harder. $1,000 is harder. 10,000 much harder. 100,000 is harder, right? And you can see it's getting harder and harder each time. Million. There's billion. No human, I don't think, has a trillion yet individually, right? And then it keeps going, and we're here. Like, that's a huge number. It's ridiculous. All right? And so that's a big number. 40 grams is a tiny amount. So 40 grams of argon is this much. Water, we're going to learn, weighs 18 grams per mole, and that's 18 milliliters. So 18 milliliters of water is this many water molecules. That's crazy. So now a mole is a counting unit. Just like a pair, which is 2, right? A pair is 2. So if you have 5 pairs of shoes, well, I think some people say that's not enough shoes, but that's 10 shoes, right? 5 pair, right? A dozen, 12, right? A score would be 20. A gross, 144, right? Then you got a mole, 6.022 times 10 to the 23rd, right? So 1 mole of anything is that many things. 1 mole of softballs would be that many softballs. And I don't think a mole of softballs exists, but there you go. 1 mole of mosquitoes would be that many mosquitoes, which would be a lot of mosquitoes. All right? So this leads us into molar mass. And this is important because we're going to count by weighting. All right? Think about this. A lot of times you'll buy at a hardware store, a lot of hardware, nails, screws, they're sold by weight. Now, it's pretty accurate, right? We have pretty good balances, but they're still sold by weight. They're not told by, this is 550 screws. It's 2 pounds of screws. Sold by weight. All right? So the molar mass is the mass of 1 mole of something. Okay? And again, we're just using a mole as a counting unit. So, like if you had 3 dozen donuts, you have 36 donuts, right? 3 moles is 3 times this Avogadro's number. So it'd be like 18 times 10 to the 23rd. All right, that's it. That's all that this mole is. But we use this mole because these particles are so small, but we have to be able to measure them and manipulate them. All right, so just so you know, atoms have what we call an atomic mass. Molecules have what we call a molecular mass. And ionic compounds have either formula weight or formula mass. But my point is, all these are still molar mass. They're all molar mass, okay? So it doesn't matter if I say atomic mass, if I don't say if it's molecular mass or formula weight. A lot of things have a formula weight just on the bottle, and it could be, right? And so it's the same thing, all molar mass. All right, so let's do the molar mass of an atom. Molar mass of an atom. So if you think about that, titanium. So if you look at the box of titanium, it has 22 Ti, and then it has 47.88. So the molar mass is just 47.88 grams per mole. Now, I like to use 2 decimal places if possible. Obviously, some of them you can't. Like lead is 207.2 grams per mole. Well, you can't use 2 decimal places because 2 decimal places do not exist. But I like to use 2 decimal places because that always gives you at least 3 sig figs, and we're happy with that. Sometimes it's not needed, right? Some of the examples we'll do soon. Right? You can round, and it's okay. But I recommend 2 sig figs, and I will be using 2 decimal places. Or it's not 2 sig figs, 2 decimal places for all of these. All right. Okay. So that's the molar mass of an atom. The molar mass of a compound is a little bit different, but it's not that much. Not that much. All you have to do is add up the atomic masses. Which is, of course, the molar masses of the atoms. All right. So if we do a molecular compound, let's use water. All right. So I have 2 hydrogens, so that's 2 times 1.008 or 1.01. I'll probably actually only use 1.01 because why not? It's 2 decimal places. And then oxygen, 1 oxygen at, so that's just 16.00. And so if I add those up, I get 18.02 grams per mole, which is the mass of 1 mole of water molecules, which is the molecular mass. Now, note, I want to point this out. This is 18.02 grams of H2O per 1 mole of H2O. That's the complete unit. We just write this grams per mole down, and we're happy with it. But this is really what it is. All right. So in our conversions and because we're going to use this to know how much we have, right? You know, chemistry is a lot like cooking, a lot like recipes. But instead of using things we can count like 3 eggs or 2 cups of water, we actually have to figure out how much water we need and how much this and how much of that. All right. And so we'll use molar mass all the time. Now let's do 2. Nope, didn't change color. 2. Ionic compound. NaCl. So Na is 22.99 on periodic table. Chlorine is 35.45. Add those up, it's 58.44 grams per mole, which is the formula mass, formula weight. But they're both molar masses. All right. Okay. And so it's just like any of these, you know, you add up all the number, and like if there's two H's, you multiply the molar mass of H times 2. If there's 5 O's, it's O times 5. If there's 3 Cl's, you add 3 times 35.45. You just add up however many they are. So again, the general relationship is that mass divided by molar mass gives me moles. And moles is going to be very important. So the number of moles, I'll put the number of moles. This is grams divided by grams per mole equals mole. Alright, we're going to need moles because our reactions react in particle ratios. And so we want to have moles because they're going to react in mole ratios. They don't react in mass ratios. Think about when you're cooking or baking. Baking's even better if you bake, right? You don't have the same amount of flour that you do sugar, that you do salt, that you do egg, right? You don't weigh them. It's not all the same weights, right? You do it in certain particle ratios. You have those particle ratios broken down for you in the recipe, right? But they're still particle ratios, and you still need them.